Alright, we're going to start talking today about the classes in Chapter 4. This is the chapter that talks about how we design our classes so that we can create objects from those. Objects in Java are software representations of real objects, such as representing people or students or teachers, that sort of thing. They can represent objects that are a little bit less tangible, like time or dates, invoices, things like that, automobiles, other kind of objects, buildings, even animals, bunnies, whatever. They all have properties and operations. So people have characteristics like their grade point average, their pay history. Cars have colors, buildings have square footage, time has hours, minutes, and seconds, and they all have operations as well. So cars can accelerate, buildings can change different things about them. An operation for a clock might be tick, which just adds another second to the clock or something like that. So the properties describe those objects, and operations give some sort of action to them. Okay, so a little bit more detail on the properties. They will use those to identify objects. So how does this make one object appear different from another object? So typical properties would be like color. So a car could be red or whatever. Fuel tank, how many gallons of gas does it have? What's the current speed that it's moving? One that people don't think of is location. Where is this? That's what sets a car apart from other cars. And also identification numbers. Those are the unique identifiers that help us to find a particular object. In this case, the car has a VIN number, vehicle identification number. Now, these properties can change, but the values persist. And what I mean by that is that you can spray paint your car a different color, but when you come out the next day, it'll still have that color that was painted the last time you changed it. Or you can fill your car with gas, and that amount of gas stays in your tank until you drive it and use that gas, and it stays there for as long as the car is in existence. As soon as you destroy the car, or in the case of Java, when you destroy the object or stop using the object, then it disappears and the instance variables are no longer there. We also want to be careful about allowing changes. I'm going to talk about that later in this lecture. So, but I guess for the analogy's sake, it'd be like, we want to be careful about letting other people drive our car or fill it up with gas or do different things with our objects. So we have ways of protecting it. Alright, operations, they are some sort of actions that will operate on or by an object. So for instance, add gas, accelerate, brake or turn, that changes the speed or the location. Gas gauge, that's just something that tells us something. How much gas do we have? So sometimes they'll change the state or sometimes reveal what the state is, and they can apply, these actions can apply to a specific object. So like if we wanted to accelerate, we'd accelerate a particular car. We're not going to accelerate all cars in the world like at the same time. But there may be methods that apply to the class of cars in general. So maybe you have a method where you just want to calculate what a car gets for gas mileage, and so you tell it how much gas it used and how many miles it went, and then it'll come back and tell you this is the number of miles per gallon. So it doesn't have to be attached to a specific car in order to find that stuff out, but if you but it could be. So, and those are different types of methods. The kind that applies to a specific instance is called an instance method, or a static method is one that just applies to the class as a whole. We'll talk more about static methods, but I just thought you might want to know about that. Right, now the class is actually made up of different members. So far, our classes have only had a main method, but most of the classes that we do in this course are designed to create objects from. And so you start with a blueprint. You start by writing the class, and then once you get that blueprint written, then you can use that blueprint to create a house with it. So the house is like the object, the blueprint is like the class. The class by itself doesn't do anything, doesn't store any data or anything like that, but once you create objects, then it becomes something a little bit more tangible that can represent a real-world object. The class members include two things: fields, which we'll refer to as instance variables. There's other types of fields too, but for this course we're going to mainly work with instance variables. And those are like the properties that we talked about earlier. And then also we have methods, and the methods are the operators. So that wasn't supposed to be there. Anyways, so we take our blueprint and then we can create objects from that. This is working out differently than I thought. Okay, so once you have that blueprint, you can create several different types of objects, or several different objects, not different types, but different objects. And so those objects can take on different values in their instance variables. Okay, so I've just created three here, where one's got a light blue door, one's got a red door, one's got a dark blue door. And so, I mean, these are like data types. With data types, you can have a bunch of different ints, right? But one represents age, another one represents the year, and so forth. So they can take on different values as they represent different things. In the same way, we can create different objects from the same class, and then put different data, different values in those objects. Okay, the instance variables. Let's drill down on that a little bit. There's certain rules, not rules, but kind of rules of thumb that apply here. Really, if you're thinking about what you should use for an instance variable, think of things that describe the object. Okay, so if you're thinking about a car, then an instance variable could be something like the amount of gas that you have, or the vehicle identification number. If you have a variable called X that you use for some reason in the class to calculate some other things, but it doesn't really represent anything about that object, then it shouldn't be an instance variable. So try to use as few instance variables that are necessary. Use all of them that are necessary, but don't have anything in there that doesn't really need to be there. If they're not necessary for more than one method, if they don't describe the object, then use local variables for those. The scope of the variable, okay, now the scope of the variable is you can have instance variables and local variables, and the difference between those is the scope. Where can those be used? So if it's defined within a method, it's called a local variable, and it can only be used inside of that method. It's only visible inside of that method. And if it's declared at the top, outside of all the methods, then it's an instance variable, and it applies to the object. And so, for instance, like a car object or something like that, you would define the vehicle identification up at the top, outside of all the different methods, and then any of the methods has access to that and can make changes to it or read it or whatever it wants to do. But if you don't, like what we've done so far is define variables inside the main method. So if you define them inside of a particular method, it can only be used inside of that method. Alright, and methods, these work with and modify and return instance variables. Classes will typically have the 4 different types of methods that you see there. Well, really the constructors, accessors, mutators, and others are the types of methods they'll have. ToString is just a specific accessor that you see in a lot of classes. So a constructor is something that executes when an object is created, and it gives you a chance to put things into the right kind of condition or the right state that you want it to be in. Accessors are sometimes called getters. We'll talk about those in just a minute. Mutators sometimes called setters, and those change the state. Accessors tell you what the state is. And then there's a number of other ones that don't really fit neatly into those things. And then, like I said, the ToString is a special case of an accessor. What that does is that takes your the different instance variables and then marshals them together, puts them together into a string that it can be returned. So, you know, a student might be made up of their ID number, their name, perhaps their grade point average, and some other things. And so that's a bunch of different pieces of information, and you can get those different pieces of information, but it's also nice sometimes to just go get the ToString, and that gives you one long string of all that information put together. Alright, UML diagrams, those are used to give some sort of a graphic diagram of the class. It usually has the name of the class and then maybe some other information. And then it shows you the relationships between the different classes. And this is something that's kind of nice because it's sort of built into BlueJ. It's helpful in design. So every time you see these boxes in BlueJ, those are really like miniature UML diagrams. And I borrowed these 2 classes from the book in the chapter. They have one that describes the die class, another one that uses the die class. And if it uses another class, then you get this dotted line between those, and it just says this is a has a relationship. It's just saying that the rolling dice has a die object. So let's take a look at this object that the authors came up with and talk about it. So this is the class definition, and they have 2 different instance variables. These are defined up at the top here. Notice that they're the instance variables are private and the methods are going to be public, and I'll talk about that in just a second. In the case of max, max is a constant, so it's defined with final, and so we assign it at 6. This is a die. This is something that you roll, a 6-sided die. So the maximum face value that you can have is 6, and so we'll use that later on in the class. And then face value. This is just whatever is on the die at this particular point in time. So down here we have our constructor, and the constructor has the same name as the class, and that's the way it knows it's the constructor. So there's a couple different things about the constructor. One is it has the same name as the class, and then 2, there is no return type. And I'll talk about return types next lecture when we talk about methods. But that's how it knows that this is a constructor. So whenever it creates a new die, what it's going to do is it's going to put 1 into the face value. And you might say, well, why doesn't it just put a random number in there? Well, it could, but the authors have chosen to just set it equal to 1, and that way it has a valid value in it. If I didn't do that, it would have been set to 0, and somebody would have, somebody may have looked at the dice, and there'd be an invalid value there. We don't want that to happen. Alright, the next method is a mutator, this one's going to change. This is actually a combination of mutator and accessor, because it's going to change one of the instance variables, the instance variable face value. I'm going to change that by calculating a random number, multiplying it by max, which is that 6, and then casting that as an int and adding 1. So if you remember from the previous class session, that will generate a number between 1 and 6. And then it returns it. So that's why it's an accessor, is it actually gives you that value back. So anytime you call the roll method, you can find out what the face value is too. There is a mutator method here, set face value, and that just changes the instance variable face value according to what was passed to it in this parameter. We'll talk about parameters when we talk about methods later on too. The get face value, this is sort of what roll does up here, except for it doesn't actually roll the dice. It just tells you what the current face value is at this point in time. And then finally we've got our toString method, and the only instance variable we really have is face value, so it converts that into a string and returns it. So it's not very exciting, but I mean, it's our first class, so we're not going to go overboard on the first class. Alright, just wanted to talk about the UML diagram. So now that we've done that, let's talk about encapsulation. Encapsulation is this concept where we kind of protect these objects that we create. So think of them as having this like protective shell, like an M&M or an egg or something like that, and we're protecting the stuff that's inside of them. Objects should be self-governing. So when you create a program that has classes, like a student class or something, if you have something in the student class where it calculates the GPA, that should be taken care of in the student class. If you have another method outside the class that's calculating that, it just makes it messier. And so this is a really simple example, but you want to try and keep all of the things that belong to the student in the student class as best you can. It's not always entirely possible, but you want to do the best you can because it just keeps things neater. And we'll use visibility modifiers to enforce encapsulation. Now, what are the visibility modifiers? Those are the public and the private that you've seen so far. So that's a 50-cent word there for you, visibility modifier, and it just means who can see these things, who are they visible to. So if you make something private, then it's visible only to the class. So we made these instance variables private, and so therefore only the class can do anything with these instance variables. So I've got all these methods in this class that use face value. I change it here, I return it there, I change it here, I return it here, and so forth. But nobody from outside of the class can access face value. Now, if they want to know what the face value is, they can call get face value, and we'll return that to them. But it's sort of like saying, well, you got to ask nice. You got to actually ask for it here. What this does is this gives us a chance, if we want, to return it in a form that we want, or in a form that they might want. So we're not going to give them the raw value. We'll give them like a formatted value. In this case, we just return the value. It's not that big of a thing to us in this case. But think of it in terms of like in time. You've got minutes, seconds, and hours. You may store the seconds in some way other than 0 through 59. But the way you want to return it to the user is, or to whoever's calling for this, is a 0 through 59. And by the same token, you have these mutator methods or set methods that change the values of those things. Well, if you had a time object, you want to be careful about not having somebody change the seconds to like 64 or -7 or something. We want to be very careful that they only use valid values for those sorts of things. So having setters and getters allows us to keep that protective shell. So we're protecting what's inside of that thing. Alright, so the variables should always be private. That's why this box is red over here, because if you ever make a variable public, then you're opening yourself up to trouble, and that violates the principle of encapsulation. So always make them private from now on. For the most part, we're going to have public methods. Those are things that provide services to clients that are outside of the class. There are times where you want private methods that are used only by the methods that are inside of the class, but we're not going to see those until later on in the semester. Okay, so we talked briefly about this, that accessors provide data to the clients, mutators allow them to make changes to them, and that's what enforces the encapsulation. So let's take another look at this. So I've got the die class. I'll compile that quickly. And the rolling dice class. Now this one just has a main method like we've done before. And so sometimes what you'll do is you'll have a program that has 3 or 4 different classes, but there'll be one class where you drive everything in the main class. You don't have to have a separate class for that. You could put the main method in the die class if you want, but there's a lot of times there's reasons to keep it outside, keep it separate from that. So just like you declare string objects, you declare objects of the class that you create yourself by using that class name. So we called it die, and I'm declaring 2 objects here, die1 and die2, and then a sum. And so I instantiate those objects down here. So I've declared them up here, and then down here I instantiate them by saying die1, I want that to be assigned to a new die object. And what's going to be the value inside of die1 and die2 of the face value variable? I'll see if you guys can answer that. If you can't, then ask me in class. And then the next thing what we do is I roll both of the dice. When I roll them, it'll change the value, and so I print that off. And then I try to roll die 1 again, and I just set 2 to 4. Then I add these things together, and I print out what their total is. And then I add the sum again by rolling these things. And let's actually try to run it. So I'm going to compile this. And run it. And so the first time it rolled a 6 and a 5. The second time it rolled a 1, and we set it to a 4. And it tells us what the sum is. And then we roll a 5 and a 2, and the sum is now 7. So there's a couple things to notice here. One is that they're taking a shortcut. What actually is happening inside of this class is that when I print this out, it takes this object, and this object is not a string. This is an object of the die class. So it really shouldn't allow me to do this. But what it does is it looks in that class and it says, is there a toString method in there? If there is, then it uses that toString method. So this is exactly the same as if I'd have written it this way and say, okay, using this object, call the toString method. But you have to do that with these other methods here, where I'm saying die1.roll, die2.roll. You give the name of the object, okay, so that's like the noun, and then you tell it what action you want to perform, and that's like the verb. So it's like noun, verb. So you could have, student take class, car drive, in order to do something with these objects. In this case, you see that in a bunch of different places here where I wanted to set the face value. I used the object, dot, and then the method that I wanted to call. So these have to be specific to the class that you're declared as. So if I wanted to print out, if I got it in my head that I wanted to print out just a part of that, just a part of the what is in there, I could say die1 dot substring starting at 0 going to 2, and then try to compile that, and it would say, well, you can't do that because the substring method isn't a method of the die class. It's a method of the string class, but that doesn't mean you can use that everywhere. So when you're programming and when you're trying to do an operation on these objects, you have to use methods that are defined in that class. Alright, that's it. So we'll practice some of these things in class, and then move on to talking about methods, where some of this other stuff will start to make sense.